This is a video about voltmeters and ammeters. Voltmeters in a circuit we draw as a V, and ammeters we draw as an A. So that part's easy. Let's say I have a battery like this, and I have a resistor here, and then we'll put two resistors here. And maybe I would like to know the current running through this resistor. So if I want to know the current running through here, first I know I'm going to need an ammeter. So I need to figure out how to hook this thing up. Now what I know is that the current that runs through that resistor whatever current runs through that resistor will continue to be that same current here, will continue to be that same current here. If I can take my ammeter and I can put it next to that resistor, then whatever current goes through the resistor has to go through my ammeter. And this is, we know that two things that are connected in series have to carry the same current, and I'm just taking advantage of that. So by doing this, I know that whatever current I've got going in here has to come out of here, has to go through my ammeter. And that would be true even if I took my ammeter and put it over on this side, it would still be true. So my ammeter gets connected in series with whatever it is I'm trying to measure. There's a little bit more though. If this resistor has a resistance of, let's say, 100 ohms, then I'm going to have some amount of current here. What I know is that when I connect something in series, I'm increasing my total resistance. So instead of having a 100 ohm resistor, I now have more than a 100 ohm resistor. What that means is that if I want this circuit to run the same as it did, I want the resistance of my ammeter to be very, very low. Now I can connect it in series, and yes, it's going to get the same amount of current, but it's not going to actually alter my circuit very much. That's an ammeter. Now the voltmeter, let's say I want to measure the voltage across this same resistor. I'm going to mark that still as my 100 ohms. I'm just going to move the marking down below. What I know is that two things that are connected in parallel carry the same voltage. So I would like my voltmeter to measure this way. I'm going to put it in parallel with this resistor. I'm putting it in parallel because whatever the voltage is across this resistor, that's what it has to be across this voltmeter, so I know these are guaranteed to have the same voltage. But I've got current coming into here, and it's going to split. Some of it's going to go up here, and some of it's going to go down here. And it's going to be proportional to their resistances. If I've got, like with my ammeter where I've got a very low resistance, if I stick a very low resistance item here, more of my current's going to go through that. The resistance on an ammeter, this might be something like a milliohm. So if I get a voltage of whatever, 3 volts running through that, 3 volts over 1 milliohm, I'm getting 3 kiloamps worth of current, and that's going to fry. If I stick my ammeter in parallel, that's going to fry my ammeter. If my voltmeter has a very low resistance, I'm going to fry my voltmeter this way. So a voltmeter actually has a very high resistance. We are talking millions of ohms. Because this has such a high resistance, there will be very, very little current that runs through there. Maybe just the tiniest amount that I can't justify drawing a solid line for, and pretty much all my current's going to go down this way. It is technically still a split, but it's like a 99.99 to 0.01% split. I do want to look at what happens when I hook these up wrong. So if I have a battery and a resistor, and I take an ammeter and hook it up in parallel to my resistor. My resistor, I'm going to stick with this 100 ohm idea. I'm going to get a splitting here. Some current's going to go this way. Some current's going to go this way. And that's with my starting current coming in. But if this is a very low resistance, then pretty much all of my current, or at least a lot of it, is going to go this way. And this thing is going to burn. I'm going to fry my ammeter by putting it in parallel, and then I'm going to have to take my ammeter, flip it over on the back. There's going to be some kind of a panel. I'm probably going to have to unscrew it. After I unscrew it, there will be a panel, and in here somewhere there's going to be like a fuse. Then I have to make sure that I've got that right fuse and replace it, and then put the back panel back on and screw it back on. There's usually some kind of a rubber coating over the whole thing, or like a silicone coating over the whole thing. It's not fun. It's kind of a pain. It's also the reason that when I personally look for an ammeter, one thing that I look for is one that has a fuse that's really easily accessible. Especially when I'm doing this for a lab with a lot of people who are just learning this stuff for the first time. These mistakes happen, but it's nice when they're easy to fix. So then, same circuit, what happens? I'm going to try and measure a voltage. What happens if I stick my voltmeter, which I know I'm supposed to put in parallel? What happens if I stick that in series? Well, if this is like 10 to the 6th volts, or ohms rather, and this is 100 ohms, my voltage, maybe 3 volts. I was going to have 3 volts over 100 ohms for 0.03 amps. Now I've got 3 volts over 1,000,000 ohms, or well, 1,100,000. Yeah, 1,100,000 ohms. So about 1,000,000 ohms. That's going to be very, very small. It's not that anything's going to blow up, it's just that my current is going to be very, very small now. So it's safe, it just means I'm going to read a bunch of zeros. This one is not safe for the ammeter. But that's it. That's what happens when I make mistakes. This is how, this right here is how to not make mistakes.